All right, tonight what we're going to be talking about is the ideal gas law. And this is different from the combined gas law because the combined gas law gives you a set of conditions and then you're tweaking some of those conditions to figure out different variables of the same type of gas. Ideal gas law, what it does is it figures out a variable for one particular condition. So like we're not changing the pressure and the volume and seeing what the new temperature is. This is just straight out, if I have this pressure, this volume, and this temperature, how much do I have? Okay, so this is called PV-nRT. Some people call it PERV-NERT, but I'm going to do PV equals nRT, also known as the ideal gas law. So let's go through what some of these things are. Okay, P stands for pressure. Pressure has to be in a specific unit. You can use kilopascals, ATM, or millimeters of mercury. I'll go into when you have to worry about what. Volume always has to be in liters, always. N is weird, I know, but it is moles. Okay, so N is moles. R is a constant, okay? And if you look at these constants, it tells you in the units what units your other things have to be in. So if you notice, every volume unit is in liters. Every amount unit is in moles. Every temperature unit, is always in Kelvin. And then the last thing that you should note is that your variable for your pressure can change. Now, what's weird that a lot of students don't understand is that this is actually its unit. Anytime you have a constant, you always tend to get these crazy, crazy units, okay? So this is actually its unit. It's not like you take the liters times the kilopascals times the moles times Kelvin. That's all taken into here. This is literally just its unit, okay? So when do you use what R value? Well, it just depends on what pressure variable you are using. If I'm in kilopascals, I'm going to use 8.31. If I am in ATM, I am going to use 0.08206. Sometimes I'll use 0.0821. And then if I am in millimeters of mercury for my pressure, I am going to use 62.4. Typically, if I'm asking you to solve for pressure, let's say, and I don't tell you which pressure unit I want you to be in, tends to be, because chemistry tends to use ATM, I will use the 0.08206. Okay, I'm probably going to abbreviate it as 1, by the way, so 0.0821. But you can use any of these, and all of these are correct. It's just your pressure unit would then have to correspond with whichever R variable you use. All right, so let's just try some problems. What volume, so I'm going to write V above it, would 12 grams, whenever I see grams, I'm going to write N, of oxygen occupy at STP? So I'm telling you its temperature and its pressure. So let's try to use if I look at this, which equation am I going to use? Well, I've got 1V, 1N, 1T, 1P. So the only equation that has all of those in it is the ideal gas law. So I'm going to do PV equals nRT. Well, my pressure is standard temperature and pressure. So my pressure, I can choose any pressure unit I want. In this case, as with usual, I'm going to do 1 ATM. Please write the units that you're using also for these equations. Your volume, well, that's what I'm trying to solve for. So that's my V, equals N. Well, N is your amount of moles. So unfortunately, I just give you 12 grams. So the first thing I need to do is I need to convert that 12 grams of oxygen, remember it's a Hober-Finkel-Hofbrinkel, into moles. So it's 32 grams for every 1 mole of O2, which means that I have 0.375 moles of O2. So I'm going to put in 0.375 moles for my N. Which R value am I going to use? Well, I'm going to look back at my R values, and the only one I can choose because I chose ATM is I have to use 0.0821, and then I'm going to run out of room. Okay, I'm going to write, and then that would be Kelvin, no, that would be liters, and then ATM over moles Kelvin. Okay, you will be given these constants on the test. So once again, you don't have to memorize them, and the units will be written with them. So you're once again not going to have to memorize them. You just have to know how to apply them. And T, well, what is standard temperature? Standard temperature is 273 Kelvin. Gosh, I did not leave myself enough room. Sorry about that. So when you solve it and round it, you get 8.4 liters. All right, let's try the next one. So the next one is what I'm going to clear this so I can write all over it. Okay, so what pressure, so I'm asking for P, would 8.8 grams, remember whenever you see grams, write N for the gas laws, of carbon dioxide exert in 4.1 liters, so that'd be my V, of this container. So this is T. So looking at my variables, I have 1P, 1N, 1V, 1T. So this is going to be the ideal gas law. So first thing I know I'm going to use PV equals nRT. All right, so my pressure is what I'm going to solve for. My V is 4.1 liters. It is in the correct unit. My N, once again, I don't give it to you directly, so I'm going to have to convert that 8.8 grams of carbon dioxide into moles. So it would be 44 grams of CO2 for every 1 mole of CO2. Round with that, you get 0.2 moles of CO2. All right, so then that's going to be 0.2 moles times my R. I can choose whichever R I want. I just have to make sure that my pressure unit matches whatever R I choose. I'm going to choose the 0.0821, and then that would be liters times ATM over Kelvin moles. And then it says it was 23 degrees Celsius, so I'm going to add 273 to that. So I got 296 Kelvin. I'm going to solve this, and I get my pressure is equal to 1.185 ATM. Rounded to the 2 sig figs, it would be 1.2 ATM. All right, hopefully you kind of have an understanding. We will absolutely be practicing more of those. Key things is, once again, this is for an ideal gas law, meaning if gases behaved ideally, like the collisions are perfectly elastic, they are perfectly elastic, and so on and so forth. But what you got to take out of it is really that you have 1P, 1V, 1N, 1T. So you're setting for one set of conditions and you're not changing those conditions. And that R value is a constant, and you'll just change it depending on which pressure unit you use. All right, have a great evening.